Hello, my name is Brian Hunt, and I'm a geologist at the Bureau of Economic Geology at the University of Texas at Austin. And today I'm going to hopefully provide an overview of groundwater flow in the Middle and Trinity Aquifers of Central Texas. Before I came to the Bureau, I worked at a groundwater district for about 19 years. And so we did a lot of research and wrestled with availability and sustainability issues of both of these major systems. And so today I'm going to talk a little bit about their connection, and hopefully it'll provide some new thoughts that folks haven't quite heard. And even though I'm doing all the speaking today, clearly I've been working and learning from others over these many decades. And so Al Brown at Hayes Trinity District, Brian Smith at the Barton Springs District, who you'll hear from, Marcus Gary, Doug Weirman, and there are certainly others that provide more fundamental or foundational geological information. Eddie Collins, Chalk Woodruff, Charlie Cairns, Pete Rose, all these folks that have done research for many years that provide the foundation for which I'll be talking about. And a lot of what I'll be pulling from today are some readily available publications. And so hopefully, these are all things that that may or may not be new to you, but I think will that do provide a credible basis for the story that I'll be sharing with you all today. So really the goal of today is to provide an overview of the hydrologic work that's been done over the last 10 to 15 years. And what I think the benefit to this is, I think a lot of people understand the Edwards, and I'll really be probably hitting more on the Trinity aspect, is that our conceptual model of how these systems each work independently and together, that has evolved over these last 10 to 15 years. And so that's the story I'll be talking about. And hopefully this will provide an introduction for some of the other virtual stops. I want to be careful that, really what I'm talking about today is the Middle Trinity Aquifer, and also for a very specific geographic area, and that is really in Hayes and Travis County. That's the Onion Creek watershed and the Blanco River watershed. That's really where I'm talking about. Some of the things that I'll describe today don't really apply to other portions, even along strike, not very far away. So I just want to be very careful about that. And with that, I want to provide some takeaway thoughts right off the bat, and hopefully I'll be reinforcing some of these takeaways here. But just want to point out that both the Middle Trinity and again the Blanco watershed, specifically talking about the surface water and groundwater, are intimately connected. So the surface water, rainfall on the hill, it comes out as a seep or a spring, flows in the Blanco River, goes back down into the Middle Trinity, flows very karstic, very rapid, comes out at Pleasant Valley Spring, which is in the Blanco River, or maybe something like Jacob's Well, which is in Cypress Creek portion of the Blanco River watershed. That provides the base flow for creeks or rivers that flow across the Edwards Aquifer recharge zone, which then goes into the ground and comes out at either Barton or San Marcos Springs. A portion of that water does stay in the Middle Trinity. And even though these systems are very much interconnected on the surface, so that is flows that either increase or decrease in spring flows that either increase or decrease at in the Trinity Aquifer, do have an effect on recharge of the Trinity. The two systems are not necessarily vertically connected in this area. And so in other words, the Middle Trinity is not flowing directly into the Edwards across these faults, as is kind of schematically could be inferred here, or vertically along faults. We think that they're actually isolated. However, there is this hydrologic connection. And the other takeaway is that really the Middle Trinity can be thought of just like the Edwards Aquifer. It is a karstic aquifer. There's big conduits, there's recharge, there's losing streams, but these two systems behave very similarly. And as such, they're also very, they're renewable because they can fill up very quickly, but they're also very vulnerable. That is to pumping that would affect the spring flow, would affect the base flow. They're vulnerable because they're karstic, into water quality, surface land practices, that sort of thing. So today I'll introduce kind of the problem, touch on stratigraphy, a little of the structure, really groundwater flow of these two systems, and then provide a summary. This map here just shows you the Edwards in blue, and then what's out west is the Trinity Aquifer in green. And of course, what's not really well shown on this diagram are the Balcones faults that stratigraphically juxtapose the Edwards on the east down to the coast, compared to the west Trinity units. And so we'll be focused today mostly along the Blanco River as shown here. Okay, and so you can see Lake Travis. For the series of maps that you see, you'll recognize Lake Travis right away, and I'll try and point out the Blanco River too. So why are we even talking about this? And that's really because current water demand exceeds supply. And especially this is evident during a drought. We can look back at recent droughts and know the Highland Lakes went down, but also spring flow and water wells had to be drilled or deepened and that sort of thing. And it's, the population of Texas is booming, and in Travis County, we know it's going to double in the next 50 years. Our water resources are not going to double in the next 50 years, but all that pressure with drought thrown on top of it really makes this a real challenge looking forward. And that's why the topic of this trip and the alternative water supplies, these are some of the tools that will have to be used to meet our needs. And so, as y'all know, groundwater in all of Texas is a private property. And so that really makes for challenges when it is such a common pool resource. You've got water that's moving very quickly underneath somebody's property to a spring. And so water marketers, for example, as shown these demonstrators, they were very concerned about a large permit that was near Wimberley that essentially would have doubled the amount of total pumping in Hayes County from this one well field. And so with multiple wells, but and they even made a book, High and Dry. William Ailey wrote that. So we're in a real litigious area when we talk about groundwater and how these systems function. And so it's good for us to try and understand how these two are related and what we can and can't do. And so in addition to those folks that were protesting, worried about their own water supply wells being negatively impacted by a large pumper, there's the impact on springs. And so, for example, here is Jacob's Well on the right. This is a Middle Trinity spring near Wimberley. When we have flow in normal conditions, it's several cubic feet per second. In 2011, was a bad drought, and shown in this black line here, and also the equivalent cubic feet per second during in August and September, when the drought was at its worst. Pumping went up and spring flow went to zero, essentially stopped flowing. This spring flowed during the worst drought of record, of course, the 1950s, when there was hardly any pumping that was going on in the area. And so other studies that Gary et al. have really shown how this is a good illustration of capture. That is the pumping that captures spring flow. So what's being pumped is essentially what's not coming out as spring flow. So that's a condition we all want to avoid, because this reduced spring flow impacts the ecology of these streams, the economy of Wimberley, and the recharge that occurs further downstream to the Edwards. So I'll touch a little bit on the stratigraphy of the area. And here we are on our map. And you can see Lake Travis up there, Barton Springs, and here's again the Blanco River. Talk a little bit about the stratigraphy and mostly in Western Blanco and Western Travis County. And I'm not going to talk much about, or at all really, about the lower Trinity, but it's a lower Trinity aquifer. It's made up of the sycamore. It's a clastic aquifer. It's the lowermost Cretaceous unit. And so all these other units, the Middle Trinity, are stratigraphically above it. This is a good aquifer in some places. It's depleted in others, but it could be a good reservoir for ASR, for example. So now we jump above the Hammett Shale, which is a regional confining unit, into the Middle Trinity, which is composed of 3 units: the Cow Creek limestone, shown here in the picture, the Hensel sandstone, which is a diverse unit, really interesting. We won't talk much about it, and the Lower Glen Rose limestone. And so we'll skip the Hensel. And here we are looking at the Blanco River, the Narrows, and this is the Lower Glen Rose, and this is a rudist coral reef that Charlie Cairns and many others, the Shell folks in the 1970s, have worked on as extensively in this area. But this also makes a good, in addition to be a good reservoir and understanding for oil and gas exploration, good analog, this is also a really good aquifer. And of course, the Upper Trinity Aquifer, which is made up of the Upper Glen Rose blankets everywhere. It's not really a regional aquifer; it's very localized. And so, so there's karst in here, and it's an important unit. But again, we're not really going to be talking about that. We are going to be talking somewhat about the Edwards. And you can see here, this is Airman's Cave along Barton Creek. And you can see the classic rotated beds and the fault zone and the conduit associated with that fault zone. So the Edwards itself, of course, is really prolific and very karstic, and most people really understand that. One of the takeaways here is that the Middle Trinity is a lot like the Edwards. Okay, we're going to touch on structure now. And of course, the big question is are these faults and structures, and again, all related to the Balcones, Miocene Age Balcones fault zone, where we've got down to generally down to the east type throw and offset on these normal faults. Are these faults barriers or are they conduits to flow? And the answer is it depends. There's some references you can kind of look at. But if we look at the structure contour of the top of the Cow Creek, so this map here, you can see Lake Travis again. Here's the Blanco River. I'm tracing it out. The contours are at the top of the Cow Creek. And that's, again, probably the most prolific of the Middle Trinity units. And so the circles are the geologic control. And what you can see is the gradients are really flat out here in the hill country. They're generally to the east to west. These lines in red shown are meant to just generalize where the largest faults are. So this fault here, for example, MBF, is the Mount Bonnell fault. It comes down and basically ends and splays down here. This fault steps over. These sort of in echelon nature of the Balcones faulting. And you've got another large throw fault that continues on. But between these two faults is deformation that creates what we call a relay ramp. And I'll talk a little bit more about that here in a second. But also want to point out this fault here, which is unlike all these others I'm pointing out, this is a down to the west fault. So this is the Blanco River. In effect, with a down to the west and down to the east, we have effectively created a horse structure that has allowed the Blanco River to incise down and expose some of those Middle Trinity units. Therefore, lots of caves and lots of karst development in those Middle Trinity units. So that's an important feature here. So these the structural style that I was talking about, again, here's this structure contour on a higher stratigraphic unit, the Walnut Formation. There's more control, but it's generally the same area. Grimshaw and Woodruff proposed this in '86. You have the relay ramp where the fault stops here and picks up back here. The beds in between are rotated, provide lateral continuity of these geologic units. We see the same here. This is the Mount Bonnell fault. Here's the San Marcos Camao fault. You can see how even this nose, this promontory, comes out and eventually dips off to the northeast. So these are the ramps that allow the geologic continuity of the Middle Trinity units at depth. And that's important for flow, as I'll show you in just a second. So if we remember on the left, this is a potentiometric map. Again, here's Lake Travis is just off the map here, I think. And here's the Blanco River. And here's Jacob's Well, there's Pleasant Valley Spring. The black lines are potentiometric lines. That is a water level map of the Middle Trinity. And you can see it generally flows from west to east. The blue lines are where the streams are gaining. That is, spring flow is coming in and you're not losing water. The red is where you're losing water. These are losing streams or recharge zones. So you can see right away there's recharge zones in the hill country, in the Middle Trinity. So both in Onion Creek and in Blanco. And again, downstream where the Edwards recharge zone stops, that is more commonly known. One thing I'll point out here is this groundwater flow from west to east. But up here, it's to the northeast, and it's because the throw of this fault is much more significant. We think that this fault is a barrier to flow. Whereas here, the relay relay ramps provide the ability for lateral flow to continue within the Middle Trinity unit. So you effectively don't see the faults in this vicinity here, whereas you do see it here. On the right-hand side is a map that really is blown up of the Barton Springs segment of the Edwards Aquifer. So here's Barton Springs here, it's Barton Springs up here. The black lines are potentiometric contours. You see this big trough. The white lines are in dive injection points, and the flow is right down the trough to the spring. So very karstic, typical of a karst environment where you have troughs and valleys that help delineate preferential flow. So I want to point out, this is I'm going to zoom in to the Blanco Valley right here. And here we have, this is a little more updated and more control on this potentiometric map. It's still west to east, but what we do see in here are troughs. And so we have preferential flow to Jacob's Well, for example, in this vicinity. So very analogous to the Edwards, that kind of flow. And thinking back to those red lines, if we think about the Blanco River, where I had blue lines sort of gaining streams, then we had losing, and we had gaining, and we lose again. Well, if we look at what that is like from the distance of the headwaters, and here's in river flow in cubic meters per second, you have gaining streams, and all of a sudden you hit what's called the dry Blanco. That's that same horst block area in the Blanco where those Middle Trinity units are exposed. The water recharges and is lost, and then comes out at springs that are just down gradient, things like Pleasant Valley Spring or even Jacob's Well. You have a gaining stream until, again, you hit the recharge zone of, you've crossed faults, and so then the Edwards limestones are at the surface, and then you enter the recharge zone and you lose water there as well. So again, just hitting the point that the Middle Trinity is a karstic aquifer in this area. So on the left, this is in that horst area I was talking about on the Blanco River. Flow is flowing into this hole right here. Marcus Gary poured some dye with his UT field class, and it came out downstream a couple miles very, very rapidly, much like the Edwards. Upland features sinkholes recharge as well. And this is in the lower Glen Rose nearby this feature, in fact. So we've done dye tracing over the years at both Edwards, of course. This on the left is on the Blanco River, and this is in the Edwards recharge zone. And we poured dye in this sinkhole, and it went to both San Marcos and Barton Springs. On the right, this is a fracture and solution zone within Onion Creek near Dripping Springs, downstream of their potential wastewater discharge and upstream of their public water supply wells. But this dye also went down through the thin veneer of the upper Glen Rose into the lower, and it hit some wells not too far downstream. So here's kind of a summary of that. Here we have these losing streams, and this poor dye, and it comes out of the springs there. Same with Jacob's Well. And here are some of those springs. These are these Middle Trinity springs where some of the dye came out. Of course, there's conduit in Jacob's Well. There's a couple miles of conduit actually in the Cow Creek that scuba divers have mapped out. Pleasant Valley Spring is the largest Middle Trinity spring in the hill country. It's a flowing artesian spring bubbling out of the bed of the Blanco River. So there's not been mapped conduits there, but there is conduit flow demonstrated from a variety of lines of evidence, but dye tracing being one of them. And again, thinking about this parallels to the Edwards downstream, when the water, after it comes out of the springs at Pleasant Valley, it flows down hill and crosses into the Edwards recharge zone. And so the map, this feature on the left, this is Cripple Crawfish Cave in Onion Creek, which is about right here where my arrow is. We poured dye in there. There's now a recharge structure on top of it to help prevent contaminants from getting in. But that came out 18 miles away at Barton Springs in 3 days. So it's definitely rapid conduit flow. On the right, this is, I just tried to highlight some of the dye tracing we did from the Blanco River that went 2 directions. So dye comes very rapidly to these conduit major karst springs. So I just want to be careful that, again, I'm not confounding folks with the idea that Edwards and Trinity are connected. They certainly are. And it's a little bit circuitous in the sense that it's really the surface water connection, the base flows provided by the Trinity Aquifer springs that provide the recharge to the Edwards Aquifer and therefore Barton or San Marcos. But pumping that would reduce these springs would therefore reduce recharge and therefore reduce spring flow. In addition, we don't think there's a vertical connection between the Middle Trinity and the Edwards, or even a lateral connection in this area. In other places, there may be. But pumping, let's say somebody were to drill through the Edwards, and this was done and proposed, and they completed a well field here, pumping here isn't going to directly affect the Edwards. However, pumping here will, in effect, over time, capture spring flow, which would reduce spring flow that's providing the base flow to the Edwards and therefore reduce spring flow in the Edwards Aquifer. So these things are connected. And how we have really demonstrated a lot of this idea of there's not a direct vertical or even lateral connection is through the use of multi-port wells that Brian Smith will talk more about. And here's a diagram that I'll skip over, but it effectively just shows data showing the heads of the Trinity and the Middle Trinity, or excuse me, the Edwards and the Middle Trinity are indeed separate, as well as geochemical values with a broad aquitard in between. So just to wrap this up, just want to remind everybody, I went through this, that the surface water within each respective aquifer is very much connected to groundwater. That is, there's karst features in the Blanco River that lose and flow into the streams and then come out right back at the springs. Just like in the Edwards, there's karst features, caves that recharge and come right out of the springs. So the surface water of these two systems is how these systems, and at least in the Blanco River, are connected. So a decrease in spring flow from the Middle Trinity will have an effect on the spring flow and water levels in the down gradient Edwards Aquifer. We don't think there is a vertical connection here. However, if there is pumping that's going on, even this down gradient of these springs, there will be capture eventually. And that could also affect the Edwards Aquifer and its springs and resources. So, I think I've already hammered the point that both of these systems are really pretty analogous. There's a lot of surface groundwater interaction. There's a lot of karst. So the Middle Trinity and this Blanco rivershed is a karst aquifer, just like the Edwards is. So these are both renewable systems. They can be replenished, but they're also really vulnerable to pumping that will reduce spring flow, so capture, and also vulnerable to contamination because they are karstic systems. So sustainability will be a pretty lofty goal. I think the Edwards is a lot closer to that because this has been recognized a lot earlier, and things like endangered species have helped advance the management of that system. And we're sort of later in the game in recognizing the Middle Trinity, its vulnerability, and how it essentially functions. And so we're a little bit behind the ball there. I'm trying to figure out how we're going to provide or manage it sustainably. Management strategies will have to include regulatory agencies, groundwater districts, special rules, special permitting. So the Hayes Trinity looking at, and this is a map showing, here's Jacob's Well. This is the Blanco River here. Jacob's Well has a designated management zone that will have some special rules, maybe some permit limits eventually, drought conservation measures, those types of things. And all to reduce this pumping so that spring flow can be maintained for both the ecology and the economy of the Wimberley Valley, and then also downstream recharge to the Edwards Aquifer and certainly endangered species that also depend on that, as well as Barton Springs as a recreational point. And what's the focus of this virtual field trip are some of these alternative water supply strategies. Brian Smith will talk a little bit about Antioch Cave and that recharge facility into the Edwards to try and get more water in there to get us through, maybe buy us some more time as we go into drought periods. There's desal and aquifer storage and recovery testing that was done in the Barton Springs segment, again, looking at Edwards, the Edwards saline zone, but then also ASR that was done as first a pilot, but now as a permitted facility that takes excess Edwards water during non-drought and banks it into the Middle Trinity and in the Balcones fault zone. So that is the strategy to extend the water supplies. So with that, I'll just point out that I do have a few more references at the end, but the plan is, I believe I'm going to stick around for some question and answer. And thank you very much for your time.